Thanks. Just what
I know that breaks are one of the fun part of these conferences, but we're on a pretty tight schedule this morning at least, because we have to conclude by 11:45 so you can listen to Jim Green's talk at lunchtime. So I hope that the folks who are outside getting their coffee will come back in soon. But I think that we're going to get underway. We have a very exciting panel coming up. There are 4 excellent papers that are going to be given. And it's a 2-hour panel discussion. There's no break in this panel discussion either, I regret. So if you need to get up, feel free to do so. But my main job here today is to keep the trains running on time so that we are, in fact, out of here by 11:45. And each of our presenters has had an equal amount of time to give their presentations. For those of you who don't know me, I'm Marcia Smith. I'm a veteran space policy analyst here in Washington, and these days I have a website called spacepolicyonline.com that builds on my very long experience at the Congressional Research Service, although I've been in a lot of other places also while I've been in Washington. I've actually been a space policy analyst for 40 of the 50 years that we're celebrating here today, so it's been quite a long time. But as I said, my job is to keep the trains running on time, and what we all agreed to is that each speaker will speak for 20 minutes, and then there will be a 5-minute question and answer period for that speaker. And that should give us 15 minutes at the end for a broad question and answer discussion. And I'm not sure where everybody is going, but maybe they're all going to have them march in here in unison. I'm not quite sure. But in any case, I am going to change the order of the presentations a little bit. Dwayne Day will be first, and then Jason, and then Roger, and then John and Andre. So there is a little switch there in the middle because it made the flow of the papers better. And just to remind you to, again, please silence your cell phones. And we, of course, encourage questions in between each of the speakers and then at the end. But as a courtesy to everybody else who wants to ask questions, when you do, would you please keep your questions very concise and directed at a speaker. So I'm going to start off with Dwayne Day. There are longer biographies for the speakers on the website and in your program, except for Dwayne. Dwayne gave the most concise biography I've ever seen. It was 1 sentence long, which says that he is, in fact, a senior program officer at the Aeronautics and Space Engineering Board at the National Academy of Sciences right now. But Dwayne is actually a very well-known military space historian, and he often writes for the Space Review, and I know Jeff Faust, who runs the Space Review, is here in the audience. There he is. Hey, Jeff. And so Dwayne is actually very well known in the space policy and space history business, and I'd like to invite Dwayne to come up now and give his presentation. And by the way, just so no one thinks I'm being rude, everybody knows that after they've spoken for 20 minutes, I'm going to come up here to the podium to make certain that they conclude so we can keep the trains running on time. Dwayne?
Thank you, Marcia. I'm reminded that this is a pretty small community, the field that we're in, and I was reminded of it even more when I looked at the agenda a few weeks ago, and I looked at my panel. Marcia Smith used to be my boss, and now she serves on a committee for which I am a study director. Also on this panel is Andre Bormanis, and Andre and I used to work for John Logsdon, who is also on the panel, and as well as Jason Callahan, who used to work with me at the Space Studies Board, and Jason now works for my girlfriend at NASA. And also on this panel is Roger Handberg, who I actually don't know, but I am sure that very soon I'm going to be working for you. So it is a really small community. And I also noticed that on the agenda there's a number of speakers who have worked on various National Academies studies over the years. In particular, a few of the ones that are up here. When I was putting together this presentation, I thought about throwing a whole bunch of covers from National Academies reports onto a slide, and I started to look, and it turns out that over the past 50 years, there have been something like 95 plus studies that the academies have done on planetary science. The exact number is somewhat iffy. But you know, that works out to almost 2 studies a year that we've done for NASA, a few for the National Science Foundation. I put 4 of them up here, and the 2 on the left were ones that I was directly involved with, and I think you can actually trace some you can directly trace some recent space policy decisions to the work that we did at the National Academy of Sciences. The one second from the left there, Opening New Frontiers in Space, we helped develop a list of possible science missions, planetary science missions that could be conducted, and one of the missions that's currently under development, OSIRIS-REx, resulted from the work that we did on that study. The study on the left, grading NASA's Solar System Exploration Program, was a midterm assessment of the Planetary Science Decadal Survey. And that study, I think, deserves a fair amount of the blame for the cuts that the Mars program got a few years ago. That was not our intention. We provided a report card on what NASA was doing in space and planetary exploration, and we gave the Mars program an A+, said that they're doing a great job, and that was used by the then Associate Administrator for Science as an excuse for cutting the program, because he figured, you know, A+ was probably too good. They needed to spend some of their effort on the things where we gave them an F. The 2 studies on the right are the 2001 Decadal Survey and then the most recent Decadal Survey. And I actually brought copies of the popular version, and I also have a copy of the much heavier report itself. If anybody wants them, I'm not carrying them back with me, so I'll gladly hand them out. And the Decadal surveys are ultimately I think the most important documents, the most important studies that the academies do right now for the space sciences. And if you've been paying attention to what's going on in the planetary science field very closely this year, you may have noticed some extraordinary things that have happened in the political aspects of it. There was earlier this year some rather startling legislation, draft legislation that came out of Congress, which essentially cited the planetary language from the Decadal Survey and then told NASA, you will do this. And of course, we have a dysfunctional political system, so that Congress is not actually turning any of their budgets into law at the moment. But had that continued, had that gone on, you would have seen, I think, an interesting example of something it turns out that has existed for quite a long time, where the National Academy of Sciences produces a report, and then Congress tells the administration, tells the executive branch that they should be following the guidance that's established in that report. This relationship goes back a very long way. In fact, the Space Sciences Board was established before NASA. It was established a few months before NASA was. But you can go back even earlier to this very famous picture here, and that picture was actually, that photograph was actually taken in the National Academy of Sciences building downtown on the mall, if you know where the Einstein statue is. You go in that building and you can find the corner of the main atrium where that photograph was taken. And there's a great account, I think it's in the Pickering book actually, that's on the stand back there, about how after Explorer 1 was successfully launched, how the scientists, they held a press conference there, and it was 3 a.m. in Washington, D.C., and it was cold and rainy, and they were in a taxi cab coming across the river, and they expected that, you know, it's 3 in the morning, there's not going to be anybody there, and they showed up, and the room was packed with reporters. This was a very big deal. I think it's an interesting fact that, you know, this was a military rocket that launched the spacecraft, and this was an American achievement. And they could have held the press conference at the Pentagon, they could have held the press conference at the White House, but where did they hold the press conference? They held it in the National Academy of Sciences building. Now, there's a lot of reasons for that. There's a lot of symbolism to that. But it makes the point, I think, that when the American space program looks for scientific legitimacy, ultimately they come to the National Academy of Sciences to look for that, to gain that legitimacy. The Space Science Board, as I said, was established in the summer of 1958, and there was an early struggle between NASA and the academies over establishing who would be responsible for establishing the goals in space science. And they came to a rather awkward compromise that NASA, of course, would be in charge because it is the executive part of the executive branch, but that the goals would be recommended by National Academy of Sciences reports. And so soon after the Space Sciences Board was established, they stood up a bunch of different committees, and one of their committees was the right up there at the top, Committee 1, Geochemistry of Space and Exploration of Moon and Planets. Now that committee existed for a little over a decade. It was one of, I think, initially 8 that were established. And over the years has been replaced by different entities. Complex was established in 1971, existed until a few years ago when it stood down for the Planetary Decadal Survey, and has now been superseded by what we call CAPS. There was also, for a long period of time, the Committee on Planetary Biology and Chemistry, Committee on Planetary Biology and Chemical Evolution, and then that was rolled into Complex for a while, and then we had the Committee on the Origins and Evolution of Life, or SEAL, which is now, once again merged into the Planetary Exploration Committee, now as CAPS. These were the standing committees that addressed the issue of planetary science for NASA. And as I said, over the years, we've had over 90 studies that have been performed, usually at NASA request, occasionally at congressional or even OMB direction. I'm going to focus on on only a couple of key areas, in key events in the history of the program, or the history of this relationship. And the first one is the Scientist-Astronaut Decision. In 1962, there was an Academy report, a Space Sciences Board report, that, among many other things, it addressed the broad range of space science issues, but among many other issues, it recommended that NASA needed scientist astronauts. It's actually an entire chapter in the report. It's a rather amazing chapter in the report because of the enthusiasm that comes through. You can see that these were scientists who were very much caught up in the excitement of the early space program. It's one of the few places where I've seen an Academy report that actually uses exclamation marks at points. They thought this was a great idea. And I think one of the things that struck me about this was that I was familiar with the skepticism within the scientific community. If you know about James Van Allen's comments about human spaceflight, if you know about Jerome Wiesner's skepticism of the Apollo program, it's rather amazing to see SSB report that so enthusiastically embraces the idea of space science and humans performing that. I think that what you see from this is that is kind of a middle position. This is a case where the academies, in some ways, diffused the skepticism that we saw in the broader scientific community and legitimized it in some ways. So that report came out, and I think NASA rather, reluctantly accepted the recommendation that was there. We don't. I see everybody looking skeptically as to where it's coming from. Sure hope it's not my phone. But what NASA agreed to do was to ask the academies to actually recommend space scientists to become astronauts. And so the academies held a review panel. They recommended 16 candidates. Most of them did get accepted into the astronaut program. And the key focus of this effort was, of course, to put a geologist on the moon. NASA accepted a geologist into the program and then put him as well as the other scientists, astronauts, at the back of the list. And unfortunately, as Apollo kept getting scaled back, that person actually, Harrison Schmitt, fell off the list. He was assigned to Apollo 18, and then there was, and Apollo 18 got canceled, and then there was some backroom pressure applied to NASA, and ultimately got him reassigned to Apollo 17, and he flew to the moon. I think it's a great case of the interaction between the scientific community and NASA to introduce science into the program. It ultimately did not have as great an effect upon Apollo as it did elsewhere, but there were a number of scientists, astronauts who did fly on Skylab and then on the shuttle, and it really opened up that program. And then I want to jump ahead to about a decade later to the early 1970s and the Grand Tour recommendation. Now, a lot of you know what the Grand Tour was. The Grand Tour was there's a planetary alignment that happens every 176 or 179 years. I forget the exact amount. But you can send out a spacecraft and hit a whole bunch of the planets as you fly past them, and it was a very rare opportunity. There was a big push for this mission, and yet in the early 1970s, the Space Science Board did an assessment where they produced a study where they assessed space science across the disciplines. So they looked at astronomy, at planetary science, at solar physics, and what they came to the conclusion that the Grand Tour mission was not a top priority. Now, there were a lot of reasons for this, one of which was that they were concerned about the reliability of the spacecraft, they were concerned about the cost of the mission. And, but ultimately, they did not recommend this as their top priority. And according to a contemporary account that appeared in Nature magazine at the time, this was a rather surprising recommendation to come from the academies. And yet, when the NASA budget came out a few months later, the Grand Tour mission was at the top of their list. They wanted it funded. And so they were ignoring the SSB's recommendation. What ultimately happened was that even though the budget process rolled forward, Grand Tour was approved, it then died a little later that summer. There were a lot of reasons for that, but if you go back and look at the congressional legislation at the time, the Congress specifically cited the lack of support from the SSB in killing that mission. Now, it got killed, ultimately got killed. The Nixon administration took the hint, and they killed the mission. There's a very good paper about explaining the Grand Tour mission and why it fell apart that appeared in 1997. It's got far more detail than I could ever assemble on this. But that paper by David Rubishkov, he actually cites the lack of support for this mission from the scientific community as the main reason why it got killed. It got reinstated shortly later as the Voyager missions that we all know about. They were in many ways less ambitious than the Grand Tour, and they were not supposed to do the full Grand Tour. But that experience at the time prompted Jim Green's predecessor, the person who was in charge of the planetary program in the early 1970s, to develop a kind of model for what leads ultimately to successful science missions getting approved, successfully approved. And he said that they essentially had to pass through 4 gates. And the first gate was approval from the scientific community. The second gate was approval from NASA senior management. And then Congress and OMB also had to approve these missions. But the key was, the initial key was getting scientific approval. And of course, that had to come through the SSB. And that leads me to a number of conclusions about this long history of this relationship between the two, which I think ultimately has been very beneficial over the past 50 years. I think one of the things, one of the benefits of this relationship is that it has legitimized the planetary science program. It's actually, Congress takes it more seriously because you have a bunch of eggheads with producing a report with the National Academy's logo on the cover. I think it's increased the overall efficiency of the program. There are fewer programs that get approved that ultimately fail to produce decent science. I think because they're going through a lot more scrutiny, organized scrutiny right from the beginning. I think it's helped assist in the legitimization of planetary science as a discipline, rather than a subset of geology or astrophysics. There are planetary science departments in various universities around the country, and you may not have seen that if you did not have the prestige that came from having a National Academy of Sciences imprimatur on that. I think it's increased the stability over very long periods of time. Right now, they're in the science program. You can trace back current recommendations that are being made through decades of SSB reports. You can find advocacy for things like Mars sample return in reports that came out in the early 1970s. You can find planetary protection protocols being developed in 1963. And the SSB really has, I think, contributed to the fact that these things get revisited again and again until ultimately somebody flies a mission. I think it's created a single place for advice and coordination across the scientific disciplines. For instance, how else would you get the astronomers to be talking to the planetary scientists on the issue of discovering planets around other stars, and what would they be looking for in the signatures when they're looking at that data? The SSB is ultimately a good place to do that. It's probably the only place that can really bring those communities together effectively. It's also created an honest broker. The SSB is not a NASA center. It's not representing a geographic location or a specific constituency. It's representing a bunch of different constituencies. And finally, I think it's led to better ties between the dispersed scientific community and the agency. NASA doesn't have a lot of scientists working directly for it. It has them spread all over the country. And the National Academy of Sciences, the National Academies, I've used those terms interchangeably, is a way of connecting them all. And ultimately, I think this all contributes to a better scientific program. So with that, I think I exceeded my time for about 30 seconds. So, okay, thank you.
So now we have about 4.5 minutes for questions for Dwayne, just on Dwayne's paper. Are there any questions? And please do come to the microphone and identify yourself and be considerate of others and make your question concise. Thank you.
Yes, Ralph.
Yes, Ralph McNutt, Applied Physics Laboratory. So, Dwayne, one of the things that has happened just recently in the most recent decadal surveys is that course, because of the budgetary issues that are always involved with doing these missions, there were these analyses that were done of the cost that would be involved for carrying out the program. And this is something new that the academies have sort of gotten into, looking at trying not only to look at the science, but also to look at the economics behind all of this. At least this is something that certainly didn't come up for the past several decades. And I was wondering if you could just make since now all the decadals are in, we've had all of these recent economic issues, I was wondering if you could comment on whether that looks like a good thing, a bad thing, something that's going to be in the future, or what?
Well, I think it's going to be in the future regardless of whether it's good or bad. Clearly, Congress and the administration want this to happen. It's now been enshrined in legislation saying that if you do a decadal survey, it has to include the independent cost estimation. There's actually going to be, in a couple of weeks out in Irvine, California, there's going to be a lessons learned symposium workshop on the different decadal surveys, and so that's going to be discussed a lot. I think what you've seen, there's always been a constant tension in SSB studies over this long period of time of the scientists being way up here looking at lofty issues versus getting down into the organizational nitty-gritty and the management issues. And the scientists would prefer to say, you know, here's the questions that we want to answer, go out and do that, and we're not going to get involved in the day-to-day decision-making on that. That worked, I think, for a very long time, and unfortunately now, because of cost overruns and because of you know, the change in emphasis within the scientific community, I think that there's been a real push to actually get them involved more in those kinds of issues. I don't want to go into whether it's a good or bad idea. I think it's good if it's implemented well, but it's very tough, you know. And it's also in some ways not fair to the scientists to ask them to kind of delve into that level of detail at a very early conceptual stage.
Yeah, John Wetmore. To what extent does the international science community participate in SSB, and to what extent do foreign space programs pay attention to your reports? They
participate quite a bit when it comes to the decadal survey. We actually had a number of foreign representatives sitting on the decadal committees. As to the degree that they pay attention, I think they definitely pay attention because they have to. There's a decadal survey can come out and can wreck their own program. So, you know, they read these things intensely. They had an intense reaction to our recommendations on Mars sample return, for instance, direct impact on them. So they're involved on both accounts.
Got a really quick question?
It's a quick question. I don't know about the answer, though. That's up to Dwayne.
Yeah. Go.
So the question is, a lot of us have noticed here in this past year in particular, a trend toward dismissing decadal surveys as being of any value. This is particularly true in the planetary area. I won't name names or anything, but I'm sure a lot of folks in this room know what I'm talking about. The question I have for you is this a trend? Does this fit into a pattern that you've seen in the past? What briefly could you say about that?
You know, I looked for trends. I had the astronomy decadal survey has been around for a very long time. And they've built up a lot of credibility over a very long time. Planetary hasn't been around as long, and so I'd be wary of drawing too many conclusions. I think give them another 10 or 20 years, and then we can decide whether or not that's really a trend. But we've only had 2 decadal surveys, and astronomy's done 6 or something like that. So I wouldn't say it's a trend yet, but that's just because I'm overly cautious.
Very much, Dwayne. And I would just ask everyone to check their pockets and their purses to make certain that all of your electronic devices are on vibrate and not on ring or buzz. Or it was a lovely chime we were listening to, but it's rather distracting for the speakers. So our next speaker is Jason Callahan. Jason has 2 master's degrees, one in international science and technology policy from GW, and another in history and sociology of technology and science from Georgia Tech. And as you already know from Dwayne's introduction, he now works for the Tauri group, but he works for Dwayne's girlfriend at NASA. So, Jason?
Good morning. So I'll be speaking today on funding planetary science. Planetary science in the United States is a public activity in that the federal government provides nearly all of the required funding, and the vast majority of that funding flows through NASA. But why does the government fund exploration of the solar system, and how does it decide the amount of money to provide to the researchers that engage in this exploration? These questions are of fundamental importance to the scientists, engineers, technicians, managers, accountants, students, and others who make up the planetary science community. Clearly, this is an uncertain time in planetary science, but is it unprecedented? The United States has suffered several recessions since the formation of NASA, and the planetary science community has dealt with limited resources and directional uncertainty many times in the past. It remains to be seen whether the current political pressures, the depth of the current economic downturn, or the increasing size of the national debt will have lasting effects on the federal budget generally, or how those effects will in turn relate to the planetary science community. But it may be informative to look back over the history of planetary science at NASA, particularly through a fiscal lens, in an effort to understand the role of planetary science as a national priority. Oops. The first thing to recognize when looking at the US economy as it relates to federal spending is that in the last 3 decades, there's little correlation between the gross domestic product and spending. That is that in the times of recession, federal spending goes up, and in times of expansion, federal spending goes up. These financial indicators over the last 5 decades demonstrate one other somewhat disturbing trend. Beginning in the late 1970s, government expenditures in red outpaced the receipts, which are in purple, consistently, and the federal debt in blue grew at a rate matching and often outpacing the rate of the increase in GDP. The result of this expanding debt is an increase in cost to the federal government in each year just to pay the interest on the debt without bringing down the principal. The cost of the interest on the US federal debt in 2010 was $414 billion, which is roughly 23 times the NASA budget that year. Now, this is not to suggest that the United States would be spending more money on exploring the solar system if it carried less debt, but it does demonstrate that an increasing debt load can place a significant burden on limited resources. And as this graph clearly demonstrates, NASA has not encountered a budgetary environment quite like this before. One of the clearest indications of national priorities is the level to which they're funded. This may seem crass, but one of the fundamental functions of government is the allocation of resources, and nearly every resource that is not money still costs money. Therefore, examining the fluctuation of funding levels in a government budget can demonstrate national priorities. Situating planetary science within the federal government is necessary for understanding the role that that planetary exploration plays in the federal government. The federal government is broken into 2 categories, or excuse me, the federal budget is broken into 2 categories, mandatory and discretionary spending. Discretionary is shown here in green. Mandatory spending involves Social Security, Medicare, Medicaid, and other programs that don't require an annual appropriations bill from Congress, where discretionary spending includes everything that does require an appropriations bill, including defense, education, energy, commerce, justice, and even NASA. The largest expenditure in the discretionary budget by far is for defense, so it's common to see budget numbers broken down into defense and non-defense discretionary categories. Here we see NASA's budget line in the context of the non-defense discretionary budget. NASA has averaged between 2 and 2.5% of the discretionary budget, and roughly 6.5% of the non-defense discretionary budget since the early 1960s. But looking at NASA since the end of the Apollo program, it's averaged less than 5% of non-defense discretionary spending. What we see here is a comparison of the non-defense discretionary line to the budget for the Department of Defense, which is in orange. If you look closely at the bottom of the graph, you'll see the budget lines for NASA, the Department of Energy, the National Institutes of Health, and the National Science Foundation. Along with the Department of Defense, these organizations receive the highest budgets in the federal government for science and technology research. I think this slide is self-explanatory. No, I'm sorry. So this graph looks at the organizations with the largest research budgets in the non-defense discretionary line. I should stress here that the term non-defense means only that these budget lines are outside of the Department of Defense and not that they're completely removed from any military application. There is, in fact, a fair amount of discourse between researchers in the civilian and military worlds, but that's outside the scope of this presentation. What we see on this graph, though, is a good representation of the shifting research priorities for the nation over the past 5 decades. In the 1960s, we see the focus on the moon landing, represented by a spike in NASA's budget in red. In the 1970s, the focus moved towards energy, and we see this reflected in the green line, representing the Department of Energy. Beginning in the late 1980s, or in the 1980s rather, and lasting for the next 20 years, we see a shift towards health and medicine in the NIH budget line, which is shown in blue. Following the spike in each of these budget lines, the general trend seems to level out a bit, give or take a few $billion. What this demonstrates is that, barring a renewed interest in space as a national priority on the scale of the race to the moon, NASA is unlikely to see a significant increase in its budget. A far more likely scenario is that the projects and programs within NASA will continue to compete for resources that are set near the current levels. Again, give or take a few $1 billion. So where does planetary science fit into all of this? NASA has averaged 1.2% of the federal budget, though this average is skewed by the massive investment in the human spaceflight program during the 60s. In recent decades, the average is below 1%. Space science as a whole, in blue here, averaged less than 20% of NASA's budget over the last 50 years, while the planetary science portion of the budget, in green, averaged about 6.5%. These averages are all a bit less if we discount the 1960s. Planetary science was the dominant portion of the space science budget in the mid-1970s. Prior to that, many of the space science efforts were attached to the human spaceflight program, and following that period, the planetary community met with increasing competition from astrophysics, earth science, and heliophysics. Between 2003 and 2006, however, planetary science enjoyed its highest level of funding ever. When we look at the history of funding for the exploration of the solar system, this graph sort of naturally divides itself into decades, with peaks in 3 of those decades and then a plateau in between. To be sure, there are not distinct breaks in the story of planetary exploration aligned with the change in decades, but dividing the story into 5 chapters helps to clarify a very complex narrative. A very brief discussion of a few of the events in each decade can help demonstrate how the interactions between NASA, the rest of the planetary science community, and government stakeholders work to establish the federal allocation of resources for solar system exploration. If the U.S. civil space program was formed as a Cold War counter to Soviet space efforts, why did the United States engage in planetary science so early in the space program, and why does such engagement continue? The answer to that question dates back to the post-war period and involves communities of researchers in fields as disparate as radio and radar research, cosmic ray research, ionospheric physics, and meteorology. Scientists in these communities began to coalesce around the idea that the data required to answer some of their most pressing questions could only be obtained by sending instruments outside of the Earth's atmosphere. A few scientific leaders in several of these space-related fields met in 1950 to determine the best path forward for their research. The outcome of this meeting was the proposal for an international geophysical year, modeled on the international polar years that were held in 1882 and 1932. The IGY took place from July of 1957 to December of 1958. The purpose of the IGY was to bring together researchers from various fields and nationalities to address fundamental scientific questions. Some of the research was not space-related, but several of the fields could benefit from instruments aboard sounding rockets or satellites. Many of the scientific questions addressed during the IGY required vast resources to acquire data, resources that were beyond the reach of individuals, academic departments, or even most military labs. By consolidating their efforts into a unified enterprise, the scientific communities were able to petition support from their governments, including military resources not normally associated with science, which led to projects like Vanguard, Orbiter, and Explorer. By the end of 1957, the space race was on, and as the United States tried to determine how best to compete. Lawmakers were consulting with many of the scientists who represented the United States during the IGY, including one prominent group of researchers who made up the Rocket and Satellite Research Panel. The RSRP delivered a proposal to Congress titled A National Mission to Explore Outer Space, which advocated a civilian organization that would allow scientists to conduct basic research similar to the experience of the IGY, but on a permanent and sustainable basis. When Congress passed the National Aeronautics and Space Act in 1958, which formed NASA, much of the language in the document echoed the proposal put forth by the RSRP researchers, placing scientific exploration at the forefront of the new space organization's mandate. In 1961, the Soviet cosmonaut Yuri Gagarin became the first person to orbit the Earth. President Kennedy determined that sending an astronaut to the moon before the Russians were able was the best opportunity for the United States to demonstrate the superiority over the Soviets in space. This decision had significant ramifications on the direction of the new space administration and on its planetary science aspirations. The moon mission became an overriding national priority, and nearly every aspect of NASA was recruited to support the lunar program. NASA's early planetary efforts focused heavily on lunar exploration, with the exceptions of the Mariner and Pioneer programs. This came as a disappointment to many in the space science community, considering that NASA, after the Mariner, or during the Mariner program, had begun planning in 1960 for a class of robotic explorers to replace the Mariner family. This new class of spacecraft, called Voyagers, would be considerably larger and more capable platforms, allowing larger science payloads. But due to several technical factors, Congress cut funding for Voyager, and NASA reallocated the remaining funds to the rising costs of its main priority, which was the lunar effort. Much of the design work for the Voyager program would appear in the Viking mission to Mars, and the name Voyager would find an entirely new project shortly. Funding for the moon mission peaked in 1967, 2 years before the success of the Apollo 11 lunar landing, and it declined through the early 1970s. For many in the space science community, however, the shift in the fortune for the human spaceflight effort seemed a natural progression. The astronauts had completed their mission, and now it was time to engage in a more robust robotic effort to explore the solar system. In 1965, a graduate student at JPL discovered a rare planetary conjunction would occur in the late 1970s. Jupiter, Saturn, Neptune, and Uranus would all be on the same side of the sun, potentially allowing a spacecraft to follow a gravity-assisted trajectory that would take it past all 4 planets. The outer planets would not align themselves similarly for another 176 years. So NASA had 10 years to plan a mission or forgo the opportunity for nearly 2 centuries. The initial mission plan became known as the Grand Tour. Planned for launch in 1979, the budget began to creep towards $1 billion, causing consternation throughout the planetary science community and Congress. Of equal importance to the budget challenges, the scientific community did not agree on what outer planets missions should take precedence. The Space Science Board, as Dwayne discussed earlier, which adopted many of the advisory functions of the Rocket and Satellite Research Panel following NASA's formation, did not fully support the mission. The Nixon administration, never a staunch supporter of the space program, favored the space shuttle over a large scientific mission, and Congress was unwilling to back a program that didn't have the support of its own scientific community. In 1971, NASA approved the Mars 73 mission, which eventually evolved into the Viking program. It beat out the Grand Tour for funding based on a lower initial estimated cost. NASA management proposed to cancel funds for the Outer Planets mission, but proponents of the Grand Tour found an unlikely ally, the Office of Management and Budget. Recognizing that this was a unique opportunity, OMB offered to restore funding to a scaled-back effort. NASA accepted, replanning the mission to include just 2 spacecraft based on Mariner designs. The proposed cost of the new mission, now called Voyager, was roughly 1/3 the amount of the cost estimates for the Grand Tour, which allowed NASA to accomplish both a deep space mission to the outer planets and the 1975 Viking mission to Mars in the same decade. We now come to the lost decade. I like this slide not only because it shows a lovely picture of Jupiter, but because the planet looks like a big 0 followed by a period, which is a good representation of the planetary science missions launched by the United States in the 1980s. Between 1974 and 1977, the planetary science budget dropped by nearly 60%. Having launched Viking and Voyager, the planetary science community expected some reduction in the budget, But by 1977, as NASA began to plan for its next planetary mission, the budgetary situation proved daunting. The new mission, initially called the Jupiter Orbiter Probe, would have to compete for a shrinking portion of a NASA budget eroded by cost overruns in the shuttle program. Strong support for another program slated to begin in 1978, a space telescope called Hubble, which had backing from the space science community, Congress, and the White House, compounded the challenging budget environment. Recognizing the difficulty of proposing two major science programs in the same year, NASA management made sure they had the backing of a unified planetary science community and worked to ensure that the Hubble supporters and the Jupiter Orbiter supporters would not sell the other side out in an effort to gain support for their respective projects. Congress approved funding for both projects, demonstrating the efficacy of the strategy and the strength of a unified space science community. Following the Challenger tragedy in 1986, the White House increased NASA's budget in order to replace the lost shuttle. The Reagan administration intended the increase to be temporary, but the incoming Bush administration decided to use the adjusted budget as the baseline to support a new direction for NASA. The budget administration wanted to push NASA to operate in a manner more reliant on innovation, taking advantage of new technologies and management concepts in order to reduce the extreme costs of spaceflight. In 1992, President Bush chose Dan Goldin as the new NASA administrator and tasked him with the mission of changing the culture from the top down. The new administrator's goal was to develop an organization less averse to risk and willing to abandon what he saw as outdated methods and thinking. Within planetary science, Goldin helped implement the Discovery Program, a class of small cost-cap missions led by a principal investigator and selected competitively from within the community. The methods Goldin wanted to implement for running the missions were characterized as faster, better, cheaper in a speech by Vice President Dan Quayle. The projects would reduce layers of management and oversight, launch within 3 years of project selection, and NASA would cancel any Discovery Program mission that went over budget. In 1995, NASA instituted the Mars Surveyor program comprised of 2 spacecraft, the Mars Climate Orbiter and the Mars Polar Lander, which would both lift off in the 1998 Mars launch window. Both missions were developed under the faster, better, cheaper rubric, but after launch, the Mars Climate Orbiter made it to Mars, but just as it was entering Mars orbit, NASA lost all communication with the spacecraft. Just six weeks later, the Mars Polar Lander arrived at the planet, and it too went permanently silent during its landing cycle. The loss of 2 Mars missions within a 6-week span did not sit well with the public or lawmakers. The accident investigation boards determined that small human errors were likely to blame for the loss of the spacecraft, but a second report issued by the Mars Climate Orbiter Board addressed the management issues that led to the error. The board found that the faster, better, cheaper strategy did not adequately assess risks in space projects. The emphasis on meeting cost and schedule placed pressures on project management to cut corners in planning, developing, and testing, and the lack of oversight meant that mistakes slipped through. In the push to change the culture at NASA, Administrator Goldin's methods seemed to have pushed too far. By the final decade of the 20th century, the U.S. planetary science community had become no more unified than any other group of loosely affiliated researchers, but they were able to find agreement in communicating their priorities to government stakeholders in NASA, the White House, and Congress. NASA commissioned the first official decadal survey from the National Research Council, delivered in 2003. That same year, NASA launched the Mars exploration rovers, and in 2006, the New Horizons spacecraft lifted off toward Pluto. The New Frontiers program selected its first candidate for the class of medium-sized missions, a solar-powered mission to Jupiter called Juno, and NASA started work on the first flagship mission to Mars since Viking, the Mars Science Laboratory, recommended in the 2003 decadal survey. Congress and the White House provided NASA's planetary science program with an unprecedented level of resources in the middle of the decade, but that level began to decline in the face of 2 wars and an economic crisis unknown in the United States since before World War II. Once more, national priorities have shifted, and the planetary science community is again faced with the challenge of demonstrating to lawmakers that solar system exploration is worthy of a significant national investment, despite a competition for resources from other sectors of governance. I just want to go back to this slide. I began researching this project with the hypothesis that members of the scientific community generally, and the space science community specifically, often did an inadequate job of communicating with stakeholders, and that this was one reason for the instability in funding seen so often in the efforts to explore the solar system. What I found was that the community actually does a very impressive job of communicating their priorities. On the whole, the lessons of the past were well learned, and most of the mistakes made today are brand new. But that's a good thing. The one place I see for improvement in communicating, both with stakeholders and with the public, is in defining planetary exploration as a national priority. Jim Green, the Planetary Science Division Director, says that the community, NASA included, needs to raise the importance of the utility of planetary science activities. And I agree. But it's not just the activities conducted by researchers in building and launching spacecraft or in the study and interpretation of the data that the spacecraft return that is of utility to the nation. It also includes the interactions of the planetary science community with other scientific communities, members of industry and academia, both here and in other countries, that provide a great benefit to the nation, a benefit that cannot be duplicated in any other national undertaking. I think the planetary science community should redouble its efforts to provide stakeholders with this perspective, in addition to the incredible scientific discoveries produced by the community's efforts. After all, given the world in which we now find ourselves, defining all of the reasons that exploration in the solar system is a national priority can only help the cause. Thank you very much.
Okay, so we have 5 minutes of questions just on Jason's paper. Again, please come to the microphone, identify yourself, and in consideration of others who want to ask questions, please be very brief. Thank you.
Mikhail Marov, Russian Academy of Sciences. Yes, I'm just wondering, how concurrent are planetary science and astrophysics program? Because usually there are strong competition chasing between two communities. How is resolved such controversial issues? Just based on SSB recommendation or some other instruments are involved?
Well, the scientific priorities for both communities are first recommended by the Space Studies Board in separate decadal surveys. But the actual selection of missions is done at NASA through recommendations of the NASA Advisory Council and, of course, the Science Mission Directorate. And then there are divisions within the Science Mission Directorate, of course, in which I'm sorry, go ahead.
For example, Kepler, how it's regarded, like it's astrophysics or planetary science?
I see where you're going.
Just an example.
No, that's a really interesting question. And actually, someone asked me the other day about the Voyager missions, which began as planetary science, are now heliophysics missions, and very soon are likely to be astrophysics missions. So it's difficult to say. I think where I tend to draw the line is if you're able to get up close and personal to a planet, I think it falls within the planetary exploration rubric. At the moment, the exoplanet program isn't able to get us quite there. I hope that will change in the future, though I don't suspect I will see a lot of that. But at that point, I think you already see a mixing of expertise anyways, a cross-cutting of fields, and I think that will continue to increase.
Hi, Michael Neufeld, National Air and Space Museum. Congratulations on the talk. It was very interesting. I liked your graphs, and I would suggest one more, which actually follows up directly with the other speaker's question. It'd be very interesting to see the budget graph of the space science program and compared how, for example, astrophysics, heliophysics, and planetary and biological sciences, where were the trade-offs and priorities over those decades and how that played out. And I also noted on your graph of launch noted, many of them were really heliophysics missions, but that's obviously very much a problematic distinction in many places.
Yeah, thanks. Precisely. Yeah, the definition of particularly in the early missions, what constitutes a heliophysics and what constitutes planetary, it really is sort of left up to the interpreter. I did, in fact, make some graphs having to do with the separation. I didn't have time to bring them. It's very interesting, and it's less complex in the early years when astrophysics and planetary exploration were somewhat similar. I mean, it was. You saw a lot of overlap between those budgets, which were difficult to sort of extract from each other in the early years. In later years, it becomes far more complex as you have more players. But you're absolutely right. It is a fascinating story.
All right. Well, thank you very much.
Thank you.
And just as a reminder, there is no break in the session, so if you need to have a break, the restrooms are out that door, and you may go at your convenience or requirement or whatever. Our next speaker is Roger Handberg. He's a professor in the Political Science Department at the University of Central Florida, specializing in space policy, national security policy, and judicial politics. He's written several books. I'll just mention one of them here because it's got a very interesting title, Reinventing NASA and the Quest for Outer Space. Roger?
Okay, thank you. This title for this particular talk was derived from a series of books done by Daniel Greenberg. He talked about the politics of pure science. His were mostly attacks on scientists who he thought were generally beyond the pale because they compromised, they did things, they made deals, which apparently he found somewhat offensive in that. But he's continued over a 30-year period. He's now on his, I think, his third book and third edition of the original book. The essential tension that I'm going to talk about is what's built into the DNA of the agency. When the agency was created in 1958, it was built as a public response to Sputnik. But it had a more subtle connotation there because it was also a way to make military space disappear. What people always find bizarre was that in 1961, Kennedy classified all military launches, which was funny because you go down the beach and watch them. You know, so there was no secrets. In Vandenberg, you could see them take off also. But what they were attempting to do was to make the space race more of a civil occupation rather than a military one. Eisenhower did it because he wanted to control space policy. He wanted to control budgets. His great fear when he started originally was that he would, in fact, end up having 3 space programs. The Army, the Navy, and Air Force already had one. And there were civilian groups out there that also wanted it. This went into, this conformed to the reality that Congress at that time was controlled by the Southern Democrats who were very conservative, but they saw NASA as political pork. It also gave them political advantages for terms of re-election. What most people don't realize is Apollo, which followed, was in fact seen by many Southern congressmen and senators, representatives, as a rerun of the TVA, except it was cover parts of the world of the South that were not covered before. Florida, Mississippi, Texas got their share on this particular context. Back to the question of NASA. NASA, when it was founded, the clear mission was human space flight, subtext military space. Space science from the beginning was peripheral. It was not what drove the people who established the agency. Initially, space science was engaged, our space scientists were engaged in a controversy whether the National Academy of Sciences or NSF should be the one to run the space science program. The decision was NASA would do it. NASA leadership came in and basically decided that space science was something they could not give over to these outside players. And to the realistically speaking, National Academy of Sciences and National Science Foundation would have found taking space science to be a disaster because it would have come to consume their budgets. It would have, it would have been too large. The other battle internally within NASA at this early stage in the space science program was a dispute over engineering versus science. Who's going to head each program or division within it? The decision was to have, if you have an engineer, then you have a space scientist as a second part. They also had to come up with a relative share. And as Callahan's talked about, he gave you a good look at the overall budget and how it's distributed across the gross categories. He did not have human spaceflight in there to make the comparison a little more, fit more with what I'm talking about here. When Apollo comes also with conflicting priorities. Apollo was a political mission. It had nothing to do with space science, had nothing to do with space exploration. John F. Kennedy was coming off a bad period. He had been humiliated, he felt, at Vienna, or was going to be, and that he was seen as very weak as a president. The invasion of Bay of Pigs had collapsed. The president was asked to intervene. He decided not to. People were talking about how he was losing it. What happened was they went out and looked at what are some things that the United States can do on a global scale that will make the point that we're still a major power, that we still matter? And so the argument was, and there was several different things proposed. Lyndon Johnson, the vice president, pushed hard for the space program to be the centerpiece. The Apollo mission was also a way to change the conversation. The United States was losing the space race. We decided to go, we're not the first in space, we were not the first human in space. We're going to jump ahead to be the first person to land on the lunar surface within a 10-year period. So it set off on the space race. In that situation, science in the Apollo missions, as has been already mentioned, was not a priority. It was clearly seen as secondary. When space science is explicit part of, becomes important is when you get to the Apollo applications program. The problem was the Apollo applications program was canceled. And what flew was, as a result, was the Skylab. They had the telescope there, but by the time they did that, the space astronomy people were fairly clear that they didn't want humans doing observations. You could do it mechanically. Now we could get messages back. You can get the images back. You can do a whole variety of things. The golden age is considered to be the golden age of the 1970s. As you saw the earlier graph, it has all the various missions that flew. They flew, my argument is, because the space shuttle was under development. Now the space shuttle becomes a two-edged sword here. What you see is that the space shuttle's development initially was on target, was moving, so the money appropriated to space science, the various missions, was not going to be touched. As you get to the end of the decade, what you begin to see is a space shuttle following behind in terms of movement, in terms of development. The shuttle engines were more difficult than they thought. The building of the tiles was more difficult. And so what you saw were cost overruns begin. So by you get to 1979, 1980, you have a problem because the shuttle program needed money. And now you have James Van Allen's famous slogan, which makes a big splash, is he talks about the slaughter of the innocents. The innocents were the space science programs that got stopped and canceled because the money needed to be pushed off to this other thing. There was also a push to go toward what we call shuttle compatibility. President Carter was asked to do two things. One of them was to approve the science mission, which is we're going to be talking about in a later paper. The second thing was he was asked to cancel all the expendable launch vehicles and move all payloads to the space shuttle. That meant space science, commercial, military, everything would go on the space shuttle. That way the shuttle generated sufficient missions to justify the cost. Because you go back and look at what are the costs of shuttle flights, what you see is things that are average across flights. Well, if you shrink the number of flights down to 5, which was what was generally the average, costs go up per mission. If you're able to add in all these payloads, then you have opportunity to say, oh, it costs not as much. The problem with shuttle compatibility is that you have to build the payload. All payloads have to be rated as safe enough to fly with a crew. And that's a major cost addition that has to take place. So what you see is that the space shuttle becomes the driver of the space science program. Money has been sucked out of the space science program to help fund the space shuttle's development. But the argument was that they'll get paid back, but the problem is the shuttle doesn't fly on a set schedule, things get delayed. More importantly, you have the problem of cost. To make a science mission compatible to fly on the shuttle, you had to add safety features and redundancies. What that meant was you saw more and more things be placed on a particular mission. Some of those instruments might be incompatible. designing became much more difficult. There was an argument made in a book done shortly after this period. They talked about the space science missions became Christmas trees, because you knew if you were going to go to a planet, you were going to have one shot at it. You might not get another shot for another decade or so. So everyone had to be on that mission. And so what happens is the missions grow larger. The problem is, as they grow larger, they have problems. And this all comes to a head in 1986 with the shuttle accident, first shuttle accident. The Challenger blows up during liftoff. This pushes back a whole series of missions, but more importantly, it undermines the rationale for having the shuttle be the single point failure in our launch program. The Air Force had built a shuttle launch complex out in California, which they had no intention of using, and they didn't. As soon as probably about as soon as the Challenger blew up, they were canceling it. They wanted to go back to the expendable launch vehicle system. What happens within NASA is everything becomes focused on return to flight, which means budget resources go toward getting the shuttle back missions to go. That's when you remember the earlier graph where the only two things flew, Angela and Galileo. Hubble flew late, 3 years late. It was supposed to be on the next mission after Challenger, but it doesn't go until 1989. In 1992, the Mars Observer dies. This was a $1 billion program. Its death was not, solvable. We don't know why. We have some technical reasons given for it. But what happens is now you get into the problem of Congress becomes involved. By 1992, there was a series of controversies over the cost of NASA and the cost of other programs. And it comes to a head in a vote on the International Space Station versus the superconducting super collider. The superconducting super collider was an international project to get to the next generation of physics. It was canceled. Congress said, no more. We're not going to spend any more money. There's an argument about why that happened. One argument is the superconducting super collider only had contracts in Louisiana and Texas. The International Space Station survives within one vote on the House of Representatives. If a vote had gone the other way, that program would have been canceled. And one of the reasons why it was so controversial, because the space science community, no, not the space science, the science community had actively publicly opposed the International Space Station and the shuttle. They saw all the money being sucked out of the sciences in NSF and else otherwise was being diverted to the human spaceflight program. Golden comes in, was talked about before, faster, better, cheaper. Faster, better, cheaper was not an effort to do more space science in the sense of expanding budgets. It was an attempt to take a set budget and carve it out into smaller pieces. The argument being if we did them smaller, we could fly more frequently, et cetera. It provides a great number of missions because it's a reversal of the shuttle compatibility problem that existed earlier. What happened with the shuttle earlier was, it cost too much. Now we can do it in these smaller pieces, and so we get many more missions. We can afford failure, which was not true in the previous situation. You have the Explorer and Discovery programs, for example. You have the Mars program is now put on this regular, supposedly every, 24, 26 months, you have a chance to launch with a more optimal thing. And so what you see in the 1990s is this moving away from the shuttle, and the space science programs begin to have greater opportunities. The Space Shuttle and the International Space Station are moving along. The International Space Station, you may or not remember, when it was proposed in 1984, it was supposed to cost $8 billion and be orbital by 1992. It missed by about 2 decades or a decade. They continue to have the recurring cost issues. For some reason, the Space Shuttle and the International Space Station have never been able to work on their budget. You know, and what they did was they imposed different controls on them. You get to 2003, you have the second shuttle accident, the Columbia's lost during reentry. This creates an opportunity that for space science is not particularly useful, because you have the vision for space exploration announced in 2004 by President Bush. President Bush was looking for a vision thing for the presidential election that year, but I will point out to you that during his re-election campaign, he never mentioned space program at all. I see people now doing, for this particular election, people are doing this, oh, what are they saying about space? You know, the point is the space program has never been a priority in the context of American politics at any level. Think about except in congressional places. But even there, you can get elected not be in favor of the space program. In Central Florida, our congressman, a couple of congressmen or so ago, he survived for 10 years, retired voluntarily. He said what we need to do away with the shuttle. You know, we need to do away with the space program. It's too expensive. He changed his mind, but it took a while. And so what I'm saying is the electorate is not responsive to these questions. What happened with the Vision space exploration is it required the shutdown of the space shuttle by 2010, which actually happened in July 2011. We were supposed to complete the ISS, and we were going to abandon it in either 2015, 2016. That's been taken out of our hands to some extent with the loss. What they were going to do is start up the Constellation program, the Ares and the Orion. The Ares is a launch vehicle, the Orion is a crew capsule. Space science, a good portion of it was now reoriented to support the vision for space exploration. That is, doing with human biology, things related to that. Money was started to go in that direction, away from planetary science and other areas. In 2010, you have a congressional intervention. I'm not sure whether it will hold or not. What it does is it talks about the Space Launch System, continues the Orion. These are the vestiges left of the vision for space exploration. On the other hand, going to low Earth orbit is no longer going to be a NASA problem, which is what the shuttle was about. It was going to be handled by commercial vendors, although that may not come as quickly as some people thought. After SpaceX did their last launch, cargo launch to the ISS, minor problem. The ancillary cargo, the space shuttle, the satellite was dumped at too low an orbit, and it's already gone. And that raises questions about human spaceflight. Reading through the different things, I recommend there's a book in the back on exploring the cosmos. If you haven't read it, you'll want to read the introductions. Because if you read through those, each of them have an obligatory section where they talk about the relationship to the human exploration issue. And it's usually negative to the space science side of the equation, because that's where the money goes. Space science has always been ancillary to NASA's vision of its future. This particular view I'm stating is not unique, but it's based on the NASA actions, not the rhetoric. I've been and listened to NASA administrators and others give great speeches about how wonderful space science is, and then they go away and they do other things. The surveys, decadal surveys, campaigns to preserve missions, for example, preserve the Hubble, to get another shuttle flight to the Hubble was done by the public, in response to the public, which usually has little impact. The community, I would argue, is now being divided because the money is going to be finite, the aspirations are infinite. And so you're going to have, and this is where, listening to some of the earlier discussion, you're going to see, splits. We're in a time of economic stress. Space science will get cut. It's already been cut. It's not immune. It has less political support in the agency at the upper levels than human spaceflight does. So if it's a choice between human spaceflight and space science, the choice is going to be human spaceflight. Organizational change. One argument may be maybe they ought to spin off space science and give it to the NSF or the National Academy of Sciences. I don't think they would take it now. Now they understand the real reality that space science is not cheap. It's very expensive and it has a significant probability of failure. This is not, what I'm saying isn't particularly new, et cetera. in that sense, but I think we need to think about that. Is NASA equipped to do space science? I would argue probably not. And in fact, the split moving to the Space Launch System is important because it moves NASA out of the business of going to Earth orbit, because that dominated for a generation or two of leadership. Thank you. Yeah.
Thank you very much, Roger, and thank all of the folks for staying on time. So we now have 5 minutes of question for Roger's presentation, and again, please come to the microphone, identify yourself, and please be as concise as you can.
Yes.
Yeah, Torrance Johnson from JPL. I was one of the guys sitting on the ground as the project scientist for Galileo during that decade of the 80s. But I'd like to note that the relationships with the human program in that era were also somewhat complex. I mean, we were dependent on the shuttle, as you pointed out very rightly. And after Challenger, many of the community felt very worried that after return to flight, that space science wouldn't get very high priority compared to national security payloads, for instance. And Admiral Truly, who was in large measure responsible for the return to flight during that period of time, put high priority on the science missions, Galileo, Hubble, Magellan, Ulysses, and got them off. And the crews put themselves on the line to get them off, even though they knew we would probably have rather gone on a regular rocket. And so, at least in that period of time, we have some things to thank the human program for.
Yeah, they were there, but the problem was they were linked because that was a requirement. Space science would have prospered even more and it would have flown more missions if they had been forced to become shuttle compatible. Probably the only one I would say that it really worked for was Hubble, because by doing it that way, we were actually able to go back and reservice it. But notice when we get to the last service mission, the then administrator was Sean, whatever his name was, O'Keefe, was opposed because it wasn't safe. And the answer is, we've been flying these missions for 20 years and we had nowhere to go. There was no safe haven at the space station. You know, so it was kind of an interesting argument that now safety is so important when previously we were flying shuttles repeatedly because we needed to have shuttles fly to keep the program visible to the public. Yes, ma'am.
Heidi Hamill from Aura. I want to pick up on your last somewhat provocative statement that you didn't think NASA was equipped to do space science. If not NASA, is anybody equipped to do it? And if so, who?
The argument of who is an interesting one because there's been talks about, NASA is an agency dominated by human spaceflight, but there's been suggestions they spin off the aeronautics part. Space, because it's clearly neglected in the context of the bigger organization. Space science, the people that you would have spun it off to 50 years ago, I think no longer would be willing to take it. The National Academy of Sciences and NSF both aggressively made moves to attempt to run the space science program. I don't think they understood what that meant in terms of long term. I don't know there's anywhere place to where it will go unless you end up with and there have been proposals over the years, none of them gone anywhere, to have U.S. Department of Space. We have some agency that is broader than just human space flight and space science. There's no easy answer. There's no organizational vehicle out there. You have to create one or one that exists. Like, remember, NASA's a derivative from NACA. NACA provided the backbone and other things were added to it. So you might want to do the same thing. Spin off the Johnson, JPL, Kennedy. Kennedy wouldn't. Kennedy doesn't matter. I'm from Florida, that's reality. So you might spin them off and create some smaller agency to just do space science.
A quick question and a quick answer.
Okay. Quick comment and question. So I wanted to challenge you on the same point. It seems to me that what NASA does get done is space science, and what it's consistently failed at for 30 years is developing a new human launch vehicle, which I believe it's tried 5 times for now. So maybe what it should do is spin off the human spaceflight side of the agency, maybe give it to the Air Force, and either continue doing space science or integrate itself somehow with NSF.
Well, we're actually doing that. That was what the new vision is. We're spinning off what the shuttle did into the commercial sector. The military would be, segments of the military would be very happy to take over human spaceflight. The problem is, now that we've established, and that would be actually consistent if you go back to American history. The military always led exploration, exploratory expeditions. We talk about Lewis and Clark, but they're the ones that explored much of the northern United States that was part of the Louisiana Purchase. So that would be a logical way to do it, but the problem is we now have 50+ years of history of non-military activity in space in that particular realm. The Soviets never bought it, but the Russians haven't either, but they have spun theirs off too. I don't know if there's anyone who could take it over presently. It require a political earthquake. It's not going to happen based on reading the stuff from both presidential candidates.
Thank you very much. Our final paper is co-authored by 2 gentlemen who are going to split their time, and they've decided between themselves how they're going to split their time, so I'm just going to worry about the total 20 minutes. And the co-authors are John Logsdon, who I think is probably well known to everybody here, even the folks out on the web, but I'll just mention that he is a professor emeritus of the Space Policy Institute at George Washington University, which he founded, and for many, many years he was the director of it. He's published many books, and most recently he published John F. Kennedy and the Race to the Moon, which really, really is interesting, and I recommend it to all of you. And Dwayne started off by talking about the connections that all of us have to John. I think Roger is the only one on the panel here who has not either been a student of or worked for John. John was my very first boss here in Washington, D.C. a very, very long time ago, and we're not going to admit how long ago that was. But John has had a tremendous influence on the field of space policy and so many of us that have taken it on as our career. And his co-author is Bormanis, who is a writer and television producer, currently working as a consultant on a new production of Carl Sagan's Cosmos television series for Fox Network. He has a master's in science, technology, and public policy from George Washington, where he focused on NASA's planetary science program. So, John, I'll turn it over to you.
So that was very clear guidance not to say what year you came to Washington, right? The idea of this paper in the context of this symposium is to extract some lessons from history to what's perceived as a current crisis. This current crisis is mild. It's a 20% cut in the planetary program. What I'm going to talk about are several occasions where the program was threatened with its virtual survival. The work that I'm going to talk about and that Andre is going to talk about really dates back first to an assignment from a long ago NASA chief historian Sylvia Fries, who asked me to look at why NASA never flew a mission to Halley's Comet. That led to a study of the 1981 attempt to shut down the planetary program, which I finished about the time that Andre came to GW for his study, and he built on that for his master's thesis, looking at kind of what happened after the program survived the 1981 crisis. So that's the origins of this. I hope we can draw some lessons for the current situation. Unlike the earlier papers, this one's pretty close to the ground. This describes people, actual decisions, the process by which those decisions are made, politics, which rears its head, I won't even call it ugly, in this process, as if, after all, public money allocated through a political process. We called it survival crisis. Is it this one? Yeah, whoop, sensitive, huh? But there have actually been several survival crises that have been mentioned in passing already this morning. In 1967, the Congress canceled a mission that was going to launch 2 Mars landers on a Saturn V, called at that time Voyager. And as a aftermath of that, Administrator Jim Webb canceled the whole planetary program, had it reinvented by a man named John Naugle, and that reinvention led to the program that was executed in the 70s. In the mid-70s, after Viking was launched, and I think after Viking was launched, and Voyagers were about to be launched, the then Associate Administrator for Space Science, Noel Henners, told Congress, we're going out of business. And in reaction to that, the lead center for planetary work, that is JPL, with a new director, Bruce Murray, tried to reinvent the program in a different fashion to get continuing support. Didn't work. And in 1981, with the new Reagan administration coming into office, the very survival of the program was in jeopardy, and that is the main kind of core of this presentation. There have been survival crises, at least of some programs since. You'll hear Scott Hubbard talk tomorrow about reinventing the Mars program out after the 1999 failures in the program. So this is a recurrent phenomena. Bruce Murray came to JPL in 1976 as director. He had been working with JPL as a Caltech professor. Many of you in this room knew Bruce, know Bruce. He's much better at giving directions than listening. See, those are the people that know Bruce. And he has a very broad-gauged view of life. And he said what JPL had been doing was dull, was putting forth gray mice for approval. And what he wanted was purple pigeons, missions that had not only scientific merit, but also pizzazz, exploratory interest, public interest. And he developed a list of those missions. You see that on the screen. And rather quickly, he decided the most purple of the purple pigeons, given the once every 76 years visit of Comet Halley to the inner solar system, was to go rendezvous with Comet Halley. Plus, a new idea had emerged at JPL. Lou Friedman will be here tomorrow, one of the major proponents of it, which were solar sails. So what, I guess, what Bruce wanted to get was a mission using solar sails to rendezvous with Halley in its retrograde orbit. That didn't last very long. The community at NASA headquarters and the space science community were very skeptical of solar sails, preferred a different propulsion system called solar electric or ion drive propulsion. Were successful in convincing NASA management that that was the only way to go, and NASA management did not put solar electric into the approval queue in time for a Halley rendezvous mission. And so the rendezvous went away rather quickly, but the magic of Halley maintained itself. And so the scientific community, and particularly the comet community, reinvented a mission that would go by Halley, and so you could call it Halley mission, but would actually rendezvous with a different comet, Tempel 2, and it would use solar electric propulsion. Unfortunately, from the point of view of comet advocates, that mission was in third in the queue of planetary missions that the community wanted to get approved, space science missions, I should say. First was the Gamma Ray Observatory, what became Compton. Second was Venus Orbiting Imaging Radar, which in modified fashion became Magellan, and then the Halley mission. It actually got to President President Carter's desk of which mission to approve, and he had been reading the New York Times science reporter Walter Sullivan's book about black holes, and he said, doesn't gamma rays and black holes go together? That sounds pretty neat, let's do that. We have an engineer-ish president making kind of program decisions. Interesting phenomenon. Through all of this, what happened was a split in the science community, and including the planetary science community, between the purists. It was still then the Space Science Board, now the Space Studies Board, that gives it a little broader mandate, that said science über alles in determining the priorities of NASA's planetary missions. And did not think it was the board's jurisdiction to look at the other aspects of the mission. Plus, people like Bruce Murray, and rather quickly with him, Carl Sagan, Lou Friedman, founded the Planetary Society, advocating for different classes of missions. So as the Reagan administration came into office, it faced a divided planetary science community. Reagan, of course, came into office with the idea of cutting the federal budget, hired as his budget director a young man named, a former congressman named David Stockman, who came to that task with a vengeance. I think he really liked it. And Carter had approved in his outgoing budget the Venus radar mission. Stockman quickly rescinded that new start, but also said to NASA, you've got to cut one of your 3 approved science missions. Galileo, Hubble, or the International Solar Polar Mission, which you'll hear about tomorrow, I think. And NASA chose to cut the joint U.S.-European, U.S.-NASA-ESA, shades of ExoMars, cooperative project, much to the chagrin of our European colleagues. And all along during this, there was this side issue of Murray going outside the normal NASA chain of command and the normal process of space science to advocate the Halley mission. There's a picture in here. I guess it's still coming. I'll talk about it in a minute. You had a new NASA administrator and deputy administrator, Jim Beggs and Hans Mark. Mr. Beggs tried very hard to get guidance from the White House on what policy it wanted for the space program, given the low budget marks he was given. He didn't get that guidance, and he started threatening, all right, if I've got to operate at this budget level, either I've got to cut money from the shuttle or stop one major activity, and the one I would pick is probably planetary. That threat got nowhere. This in a letter to OMB, to David Stockman. You can read it, but the bottom line is not only end the planetary program, but de-access JPL. It would make JPL surplus to NASA's requirements. Good question of whether Beggs was serious or playing the Washington Monument game, you know, putting forward a proposal he thought clearly was not acceptable. Problem was, it was acceptable. And OMB, when it came back with the NASA mark in November of 1981, not only had no money for future planetary, but cut Galileo, which would have had the effect of ending the planetary program. With a final decision to be made in December, with the staff support at the White House level, the OMB paper said, even though it's successful, we've got to cut it if we are going to save some money. And the new science advisor, George Keyworth III, saying cutting the program is good management. So your staff support at the White House level for the space program was urging the end of the planetary program. Who were involved in this politics of decision-making? There's the picture I wanted. These are the three founders of the Planetary Society, Bruce Murray, Carl Sagan, and Lou Friedman. Lou's hair then was dark. I wonder whether mine was. in the late 70s or 1980. The other person was one of the early advisors to the Planetary Society named Harry Ashworth. They had started the Planetary Society to campaign for the Halley mission and had flooded the White House with thousands of letters which were never opened, which were sent to NASA, but advocating a single mission, not the planetary program at all. The planetary science community was debating whether it should get into the political advocacy business or whether that would stain the purity of their scientific advice. Say the public was involved through the Planetary Society. The people that counted were the people that were worried about the future of not only JPL, but Caltech. And there had been a trustees committee on the future of JPL formed at Caltech, chaired by a woman named Mary Scranton. She was a wife. You have to be old to remember some of these names. She was the wife of the former governor of Pennsylvania, Bill Scranton, who had run for president, and herself a very effective operator in Republican politics. Then the Democratic president of Caltech, Murph Goldberger, got involved in this, and they started coming to Washington and trying to exert their influence on this. And at the end game, they were successful. Nothing that the community did on its own would have produced the result. They got to people in the Senate, and in particular got to Senate Majority Leader Howard Baker, and convinced him to write a letter directly to Ronald Reagan supporting the planetary program, and he did. Whether that letter ever got to President Reagan or not, it produced the compromise to have enough money to allow Galileo to continue and to give the program, having kind of nearly escaped death, time to reinvent itself. And that is where Andre comes in.
Thank you, John. Thank you, Marcia. Hope is this the remote? Great. So, as John said, in the wake of this near-death experience, there was a perceived need to try to come up with a strategy, a way of ensuring that this kind of thing was not going to happen again. And already in late 1980, the NASA administrator at the time, Robert Frosch, had approved the creation of an ad hoc subcommittee of the NASA Advisory Council to specifically develop a strategy for solar system exploration in the 1985 to 2000 timeframe. It was led by John Nagel, who we mentioned earlier, a physicist who had worked at NASA in their science effort in the late 60s and early 70s and had a very successful run there. So ultimately, the SSEC, Solar System Exploration Committee, developed a plan based on 3 classes of missions. And Dwayne had mentioned earlier that COMPLEX had been around for a while, the Committee on Planetary Exploration. Essentially, they had assigned priorities to unanswered questions regarding the solar system, its origin, its evolution, the evolution and origin of life, and so forth. SSEC was trying to turn their priorities into a series of missions. And they came up with 3 classes of missions that they wanted to propose. In the $100 million range, observer missions. These would be based on commercially produced Earth-orbiting spacecraft. A so-called Mariner Mark II mission, which would take the venerable approach of the Mariner missions and try to standardize that into a common bus that could be used for a variety of missions to the outer planets. And finally, more in the sort of Bruce Murray Purple Pigeon class, so-called Viking missions, which would potentially, cost on the order of $1 billion or more and do big, high-profile kinds of science and exploration. So they produced a report, a core program. They had to choose between a so-called balanced program, where they basically tried to satisfy as many interested parties as possible, or focus on a particular scientific question in planetary exploration, they went with the balanced program. Their proposed core missions for new starts in the 1980s were the Venus Radar Mapper, which became Magellan, which was launched on the shuttle Atlantis, I believe in 1989 or thereabouts. Mars Geoscience Climatology Orbiter, which we will talk about again in a moment. Comet Rendezvous Asteroid Flyby, CRAF, and the mission that later became Cassini. These were two Mariner Mark II spacecraft proposals. So, we all know that Magellan went on to have a very successful mission at Venus. The observer side of this equation, these small $100 million missions based on existing commercially developed spacecraft, never really took hold. It was pretty clear as they were developing this, this Mars orbiter that there was never going to be an observer series. The one spacecraft that was likely to get off the ground, get to Mars, was later what was called Mars Observer, and of course, been almost 17 years by the time that spacecraft was launched since we'd sent a mission to Mars. Everybody and his brother who had an interest in Mars wanted to get an instrument on that mission, and naturally the costs grew exponentially. Mariner Mark II for both CRAF and Cassini was considered a way to save money by getting this common bus developed. Unfortunately, that was also an idea that never really took hold. As Jason pointed out earlier, when the Mars Observer spacecraft approached Mars, it fell silent, possibly due to a ruptured fuel line that may have sent the spacecraft into an uncontrolled tumble. This is one of the few images that we returned from Mars on that mission. And again, the idea that we could establish an observer series for missions to the inner planets based on commercially developed spacecraft was unfortunately a good idea that just never came to fruition. CRAF was a troubled program on several levels. Primarily, I think technical issues, at least initially, were a problem for CRAF. There was an instrument, a penetrator, that was going to be launched from this spacecraft into the surface of a comet and return data from in situ measurements of the ices and minerals and so forth that we'd expected to find in a comet candidate. Problems with the development of the penetrator added costs. Somehow in the budgeting process, CRAF was allocated only something like $250 million, whereas Cassini, the mission to what became Cassini, mission to orbit Saturn and drop a probe into the atmosphere of Titan, received the lion's share of the budget on the order of, 1.4, 1.5 billion at some point. So CRAF was considered not the sexy mission of the two. There was a perception that one could argue with that this Saturn orbiter would be of much greater interest to the public, and CRAF ultimately kind of became contingency money for the development of Cassini. So, John and I will talk about these last couple of slides, the Discovery Program. Oh, no, I'm sorry. Oh, we were supposed to go to I thought John and I were going to do conclusions together. That's my mistake. We had 20 minutes. Well, then let us both take questions, and you can look at this slide while we're doing it. How's that? Thank you.
So perhaps I'll ask the first question. What were your concluding remarks?
It's very kind of you. Basically, that, as John mentioned at the beginning, there have been a series of crises in the program, and it's, it's likely to continue. What I find kind of astonishing is not so much the fact that, we don't spend a lot of money on planetary exploration, but we spend as much as we do. Considering the history of NASA and the program and considering the budget environment, I think planetary science is probably doing pretty well for a field that was essentially invented in the early 1960s because of other needs.
Yeah, I would add to that there is stability in the program. Discovery line missions continue, and they don't seem to be very controversial. The issue is for the community is whether it's going to get the big flashy missions that were in the decadal survey or not. And I think what this whole history suggests is that that's not going to happen purely on scientific merit alone, that there really does need to be some added dimension of public attractiveness if the community hopes to get the things it really would like to do. Got questions?
Alan?
Yeah, Alan Ladwig from NASA. You just mentioned that to do some of these bigger things would have to have something to attract the public. And one of Jason's concluding thoughts was that the space science community needed to make space science a national priority. How do you see that happening, and what would the mission have to look like to make space science be a national priority, given the history you just went through?
Andre's in the public entertainment business. Let him answer that.
I really see nothing on the horizon that could make it a national priority. I think we have so many other priorities today that, something astonishing like the discovery of evidence of past life or present life on Mars, I think would certainly raise the profile and make it probably a national priority at a greater level than it is today. I think it would take a discovery of that magnitude to sort of really direct more substantial resources toward planetary exploration these days.
And getting out to Jupiter with the Juno mission and finding something really exciting out there might energize the Europa mission that everybody wants to fly. But a good job of salesmanship needs to be done in packaging. We're back to the era of purple pigeons. I mean, what are the purple pigeons for the 2020s, I guess is the question. Mikhail?
Mikhail Maro. John, I would like to return you back to beginning of 70s. It was the time it was a great excitation behind the planetary missions, both in Soviet Union and in USA. And it's not accidentally, just at that time, the first NASA delegation came to Moscow. It was headed by George Low, Deputy Administrator for NASA, Noel Hinners, John Noggle was one of the members, and I had a chance to be in the Soviet delegation, which was headed by former president of Soviet Academy of Science, Mstislav Keldysh. And in 1971, the first agreement between NASA and Russian Academy of Science was signed. And the first in the history joint working group was set up. And it was headed, co-chaired by Noel Hinners, also you mentioned, and myself. And we just work very actively, developing different kind of plans. And at the first issue, for example, it was some kind of the bridging during operation of Mars 3 and Mariner 9, just at the real time, information exchange. It was absolutely incredible for the people who sat in the deep space, deep network in Crimea and just suspected me even just being American spy, Absolutely well, fantastic. Okay, so the question is, it's quite well developed. Just until Reagan administration came to the office, and it was absolutely abruptly canceled, all cooperative efforts. So the question is, do you think there are still some ground in order to make this cooperative program more solid, or there was no chance, regardless which administration came to the power?
Yeah, you look back and you see missed opportunities. Not only cooperation in robotic space science, but also cooperation in human spaceflight. Little known is the fact that the Apollo-Soyuz test project was supposed to be the first step, followed by a shuttle rendezvous with a Soviet space station, and then joint work on a space station. That was canceled not by the Reagan administration, but by the Carter administration after the invasion of Afghanistan. and really resuscitate it under the Reagan administration from 1987 on. But the broader issue, and it shows kind of the tragedy, editorial judgment, of the withdrawal of the U.S. from the ExoMars cooperation, is international cooperation is one of the themes that could elevate planetary exploration above pure science to something with political and international significance. And the fact that we've chosen not to pursue that path is unfortunate.
Thank you very much. We're going to move to our broader panel discussion. Thank you, John and Andre. So all the panelists, if you could sit in the order in which you spoke, people remember which speech you gave. So Roger, if you could sit in the middle, and Jason here, Dwayne at your podium. So Bill, do we absolutely have to be done 11:45 or is 11:50? Okay. What? 11:46. All right, we have until 11:46, so it's a few minutes anyway. So, Greg, did you still have a question? You don't have to sit down just because their talk was over. So,
thanks, Marcia.
And again, say who you are, and please be considerate of others by being brief.
I will be. Greg Vane from the Jet Propulsion Lab. This is an observation which will lead to a question very quickly. About 15 years ago, Charles Alachi, who was then assistant director at JPL, working for Ed Stone, marshaled planetary scientists from across the nation to come up with a roadmap for solar system exploration. And through force of will, he managed to get everybody to come together on the idea of search for life. And it was really interesting how much resistance there was in the planetary community at that time for fear that we would have another Viking incident here where you went to find it and you didn't find it. So the question is, and in fact, one of you did in fact pick up on this as a potential theme for rallying the public support that we need in order to secure a future for planetary. Could you guys expand on that? Do you think that that is a genuinely serious prospect for moving forward? Is that a theme that will help us unite the public?
Well, Andre, say you write this stuff, so...
Well, I have a certain bias in that sense. I'm particularly, and I think most people are particularly interested in the question of whether or not there is life on other worlds. If you talk to people casually who are not working in the field of planetary exploration or space science, I think that that's the question that most frequently comes up. But of course, we have no idea whether or not we'll be able to answer that question in the foreseeable future. So
does that make it a rationale that continues into the indefinite future, or something that could lead to failure?
Well, both. You know, I mean, it is a rationale for looking at the spectra of some of the exoplanets we've been discovering. We have missions, at least on paper, that could conceivably do you know, the kind of infrared spectroscopy you would need to characterize the atmosphere of an exoplanet orbiting another star and determine whether or not there are chemicals out of equilibrium, methane and oxygen and ozone and so forth. And I think that that's very exciting. That's a pretty long-term prospect, and there is no guarantee of success. You may look at all these planets and discover that, you know, there's nothing much of interest there, or maybe you know, maybe the technique will prove to be inadequate to the task. So there is a risk on that side of it. But just in terms of, I think Dan Golden was a big advocate of this in the early 90s, of this question of what's NASA, origins. What's NASA really about? The origin of life, whether it exists elsewhere in the universe. I find that probably the most compelling question that NASA could potentially answer. Whether or not that's enough to generate greater public support for a more strategic approach to the answer to that question, I leave that to others who are much better versed in the politics of it than me.
Does any other panelists have a burning addition to that, or shall we move on to the next question?
I would say one thing. The problem with finding life is you have scientific finding of life, and then you have movie finding life. Unless we find a skeleton with a guy with a club on Mars, I think it's going to be a very abstract kind of question. I mean, you saw that in all the discussion about the meteorite, which allegedly had, you know, something, and NASA ran with it. And after the scientific community got done with it, there wasn't much left except a few burnt spots on the ground. I mean, that's reality. You know, I think that life, if we had Either they come to us or we go out and find them. I think the public doesn't care which way we do it. The problem is they want real life, not what we talk about. Oh, you have a few bacteria. You know, did we bring them with us?
Okay, there's a question on this side.
Can I pick this up? It's a little awkward speaking from there. Hi, thank you so much for your interesting papers. Janet Fertesi at Princeton University. I wanted to push on an interesting tension that I noticed across some of the papers, in which there was a back and forth between a kind of more personal voice and then a more institutional voice, and that came a lot through the use of the passive. So I heard a lot of Congress allocated, or craft just didn't seem to be as sexy. And I can't tell who or if the historical actors were that were behind making that actually make a difference. And I think that really came to the fore in John's talk, when suddenly there were people, individual people, that were very important in producing an institutional moment. And I'm wondering, for the papers that you've discussed today, although I'm a sociologist, I completely understand the importance of taking a macro and an institutional view. If there are some moments in some of those historical moments that you discuss in which there are individuals whose role has really made, whose voice has really made the difference in steering that larger institutional ship.
From my own perspective, I think that what you're seeing is trying to compress 40 pages of a paper into a 20-minute presentation.
Of course. And it's not a
I certainly dealt with a lot of that.
invitation.
My impression is that most of the major decisions made regarding planetary science do have to do with human personalities. I think it's a tremendously important aspect to consider.
You know, I skipped over in a slide. It was on the slide, the position taken by the NASA Deputy Administrator in 1981, Hans Mark, who thought that planetary science was kind of trivial and believed that astrophysics, which had by that time a decadal survey, had plans for the grand observatories, was a higher priority area of science. And Dr. Mark was able to get that position into the NASA position in his period in Washington. So certainly personalities in positions matter in making decisions. That's those of us that live in this town, you know, thrive on that.
Ralph, you get the last, final, brief question.
Yes, ma'am. So a slightly different question about, sorry, John, I don't want to block the camera here. Slightly different question about the resources and educating and PR and all that. Is part of the problem that we as a technical community have not appropriately educated not only the public but also the non-technical decision makers about how much it really costs to build a flawless purple pigeon? Is that part of the problem? And again, that's sort of turning the whole issue of resources on its head. But there was a 7 minutes of terror with Curiosity landing, but it works, so no problem. We can do it again, right? It's easy to do. And is that part of the problem? Do we need to be doing a better job?
Well, success creates expectations, and you want success.
Right.
So it's a dual-edged sword, I guess. I would add, Ralph, that one of the issues is educating the scientific community that appealing to the public is not dirty. It's not unseemly to tell stories. That putting a narrative like the 7 minutes of terror, which I think was a very effective narrative, because once you get Curiosity down there, then everybody's focused and say, huh, now what? Let's see what it does. But it really focused on the spacecraft. I think it was great PR. And a little submarine going around the oceans of Europa, gets the image of that, or a Mars airplane. I mean, there are images of stuff. You folks at JPL are going to have fun trying to capture something like that with Pluto when you get a few blurry images. But never mind.
I'd just like to add that you asked about educating the public on how this stuff, how come this stuff costs so much, and I got to say, I've worked in this field for quite a while, and I still don't know why it costs so much. I mean, I've been on aircraft carriers that cost $2 billion, and then I've looked into clean rooms, and somebody points to the spacecraft, and that's $1 billion. And the aircraft carrier is a heck of a lot bigger and has nuclear reactors. And I honestly don't understand why some of these things that are not physically big objects cost so much money. And so if I don't know it, if I can't figure it out, and I've been doing this for a while, I think it's a really difficult thing to try and explain that to the general public, which of course doesn't know the cost of, doesn't know how much we spend on a lot of different things that the government provides. So it may be an impossible task.
And I'm afraid that we're going to have to continue this at lunch. About 30 seconds, can you do it?
Yeah.
Or, okay.
The Curiosity landing was important because it was 7 minutes of terror, everybody understood this. But what was the next image? Curiosity's using its shovel to see if it works. Now that's scientifically very important, but that's not exactly grabbing the public's attention. Something they think looks like a lawnmower reaches out with and pulls in some dirt. And so I think it's hard to do it. You can do the 7 minutes of terror, but what happens after that? The science, which is not going to be attention grabbing unless you're a scientist.
Well, I think we've had a very provocative discussion to start off the seminar. It's going to be an exciting day and a half to follow this, starting with Jim Green's talk in just a few minutes. And I'd like to thank all of you for being such a wonderful audience and the panelists for being fantastic about keeping to the time constraints.